Welcome to the channel Exam Ignite. Continuing of the series of electromagnetic theory lectures. Today we'll start with the module 4, which is containing of two topics: magnetic force and the magnetic forces and the magnetic materials. Already the 3 module videos are uploaded. Please check the description box for the links. Magnetic forces, we study about the force on a moving charge, then differential current elements and force between the differential current elements, which is a very important derivation. Next comes magnetic materials. Here, magnetization and permeability, magnetic boundary conditions and magnetic circuit discussed in the part 2. Starting with the part 1, firstly, Lorentz force equation. We have to consider a point charge, that is Q. Let V vector be the velocity in the uniform magnetic field of magnetic density B vector. So what will be my force? Force will be equal to charge into velocity into the magnetic field density, that is Q of V vector into B vector. Consider that as equation 1. Taking the magnitude of that F1 vector, we get QV B sine theta. Take that as equation 2. You have to write the diagram which is shown in the right side. So theta, it is forming the angle between the velocity vector and the B vector. Velocity vector and B vector. We know that Q is under the influence of what? Electric field of strength E vector. So this is a plane of magnetic field density and a moving charge, and this is a plane of force. Okay, so Q is under the influence of what? Electric field here. So F2 will be equal to, as we know the formula, F is equal to Q into E. When it is combined, the resultant force that is acting is F1 vector plus F2 vector, that is taking the Q common out, we can write it as E vector plus V vector into B vector. Next is force on the differential current element in B vector. So consider a differential element of the length dl of a conductor. Rho v is a charge per unit volume in conductor. dq is a charge in the element. dq is equal to charge density into the volume of differential element. So that is rho v into dv. dq will be what? Rho v into what is the volume? Volume, that is area of cross section, into dl, that is A into dl. I will be the current flowing through it. So B will be the magnetic flux density and dF is the force experienced by the element. So we can write dF is equal to dq of V vector into B vector. dq, substitute it as rho v dl into A and V vector into B vector. What do we get as velocity? V is the velocity of the charges. So here we can take the V out and send the dl in inside the bracket. That happens to be the I. That is I is equal to rho v into V into A. So that is given as I. So dF is equal to I into dl vector into B vector. On finding the magnitude of force, dF is equal to I dl B sine theta, where theta is the angle between the direction of B vector and the I. This was all about the two main important derivation which is expected in this module. For the next concepts, do refer the part 2 video. Thank you.